We're going to be working through a bunch of questions. The first bunch here have everything to do with these first four graphs. So we're going to take a look at these graphs first and make sure we understand what they are. So a group of students recorded a video of a ball being launched from a mini cannon. They imported the video into Capstone and produced the four graphs shown below. And then we're going to use these. So this is an X position versus time graph, okay, of the projectile. This one is the Y position of that same projectile. This one is the X component of velocity versus time. And this is the Y component of velocity versus time. And for part A here, we're asked to write the equation of the trend line, the mathematical model, and the theory. All right, so let's do that. So we're going to start with the first one. And for this one, we need the equation, the trend line is not shown, so let's figure that out. So we've got y equals mx plus b. B is going through the 0, 0, so we don't have a b. So let's just find the slope. So the slope is we're given these 2 points. So we can do 1.34 and 1.88. This is going to be 0.09 and 1.501. I had to get my calculator. It's across the room. So this is 1.25, and on the bottom, 1.868 minus 1.51, 0.367 is 3.406 meters per second is my slope. Okay, so the equation of the line is that. All right, so let's go over here. So we're going to say y equals 3.406x. This is x position, so this is going to be my dx equals 3.406 times time. The theory is this. This is just a kinematics equation. This is 0. Okay, so that's for A. Next, for graph B or graph 2, sorry, this is graph number 1, this is graph number 2. They gave it to us, we've got y equals negative 4.78 t squared plus 13.9 t, oops. Equation of the trend line first. Plus negative 9.29. So this is going to be my x position, my x distance. It's going to be negative 4.78 t squared plus 13.9 t minus 9.29. And the theory is dy equals voy t plus 1/2 at squared. Graph 3 is up here. So we've got here we've got a slope. This is actually supposed to be a horizontal line. I can see that here, right? Because the r squared is so poor that this is most likely supposed to be a straight line. So I'm actually going to well, let's write it out. So I'm hesitating for the following reason, and we should probably talk about this anyway. Okay, there's two issues here. One is, clearly this is supposed to be a horizontal line because my r squared is poor. Okay, as opposed to this one or this RMSE, remember, is the opposite of r squared for a curve, so this is actually really, really good. So that's what we're looking for here. This is telling me it's supposed to be a horizontal line, therefore I need to just find the value of what's hitting this here. And my y-intercept isn't going to work because I'm at, look at my time frame, right? The whole beginning of this wasn't part of the tracking, so it's taking, the y-intercept is where it would hit 0. So that's not going to be helpful either. So what I've got is I've got this value and this value, and I'm going to use the average here. So you could do this on your calculator, of course. So divided by 2, and I'm going to get an average of 3.5 meters per second. And why is that important? Well, because I know that Vx is constant, right? It's going to be an actual value. So by theory, right, it's going to be a constant. So this here isn't going to be that helpful. And sometimes you have to use your judgment when you're looking at your data and not blindly follow it. So we'll talk more about it in a second. All right, let me finish that. All right, so now the next one, for y equals negative 9.47 x plus 13.8. The mathematical model is my y velocity. That means that my theory here is Vy equals a times t plus v initial y. Right? We usually write it v initial y plus at, but I put that piece there. All right, so now we're going to use these to figure out some values, now that we've got that. So for each of our responses, what graph we used, what information on the graph we used, and why it was relevant. So what is the initial velocity of the projectile? So the initial velocity is going to, we've got our constant here, right, which is going to give you Vx is 3.5 meters per second. That's our x component of the velocity. The initial y velocity is 13.8. So we've got that piece. What's the hang time of the projectile? The hang time is going to be, you can read it off of any of these graphs, right? Because they're all pretty much the same. We've got 1.834, 1.834. So that information is given. I see a mistake actually. VOY is not that. If you look here, what is the initial speed? It's right here. Right? So VOY is negative 0.78 meters per second. So where did we get this? This was from the y coordinate on graph 3 and 4. That's what we did for these. We used the y coordinates. This one is from the x coordinate. So we actually need to, this too, we need to do this better. So we're going to use the x coordinate to find the total hang time in the air. So if we ought to do from where we start to where we end. So we ended here, but we started here. And you can use any of these to do it. So we can say 1.834 minus 1.534. So that's going to be 0.30 seconds. That's our hang time. And it should be pretty much the same for all of them. 0.501 to 0.1868. It's not going to be exact, but it's pretty close for all of these. Okay. What is the range of the projectile? That's the total distance traveled on the x. So the range, we're going to look at our x position, and that's going to be the total distance traveled from 0 up to 1.34 meters. That's our y coordinate on graph 1. What is the y acceleration? Well, I know, do you know, that the slope of the VT graph is going to be acceleration. So the acceleration is measured at negative 9.47. We know it's supposed to be negative 9.8. Okay. What is the x velocity of the projectile when it hit the floor? So how fast is it going when it hit the floor? That's the final velocity. That's 3.53 meters per second. That's the y coordinate. Graph 3 at end. Same thing for y. The y velocity is negative 3.88 meters per second. So at the end. The x acceleration of the projectile is going to be the slope of this graph, which should be 0, right? So we didn't get very good results for that. This is a repeat of E, so we don't need that again. With what type of motion is the ball moving on the x-axis? Well, if you look at this, it's pretty much constant speed. You can see it there, or you can see it here. See, this is a nice straight line. With what type of motion is the ball moving? Well, let's put either graph 1 or 3 will tell you. What type of motion is it moving with on this? Well, here you can see it's increasing in the negative direction. Here you have increasing in the negative direction. So either one. Okay, so that will bring you through interpreting these capstone graphs, which you're going to do for your own as well.